Hello, this is Zekushon from Twitter. Today we're going to talk about setting the KA flags on your own kernel. I have already made a video about this in the past, but it seems I was missing a couple of stuff to do first. So let's begin. Some requirements. You need IDA Pro for this. Don't ask me where to get this, because it's illegal to get a cracked version. You also need Socratic Bliss's kernel loader for the PS4. You can get it here on this link. So you have here the kernel loader. You click here, you click on the raw, you right click and you click on save pages and you save it on the desktop, save, and you can find it here. Then you go and you need a PS4 Kernel Dump, which can be done with any decent PS4 host menu that supports this, such as AlAzif, Karos, Leefuls, PRBs, etc. I have here a kernel dump from 5.05. If you go here to the kernel dump and you search release branches, you can see here that's 5.05. Okay. You also need an hexeditor like hexd or any hexeditor of choice, and you need Notepad++ to note down the changes you make. So I'm going to use this Notepad++. So let's begin. Yes, and you also need the Kernel Magic, which I already talked in the other video, found in keys page. So if you go here to the PS Dev Wiki /PS4/keys page and you search for Magic, you can see here the Kernel Magic, and you can just copy it and go here and paste it here. Okay, so let's start. First we go to the kernel dump, and then we go to the Kernel Magic. We search the Kernel Magic. If you might remember from the previous video, the place before the Kernel Magic are the KA flags, and the place after the Kernel Magic are the token flags. Only 4 bytes are used by Sony, these ones and these ones, and they only do this because they decided not to use any more bytes, but if they wanted, they could use a lot more bytes. For example, here it's on 5.05. You can see that 1CD06A8 is the first byte. So you go here to your Notepad++, 1CD06A8 it needs to be a certain value. So what I thought about in the other tutorial was to set all these values to FF, so it can set automatically. So you can just do this equals FF, then you continue and you go to 9, then to A, then to B, to C, to D, etc. But since only the first four bytes are used, you can just do this. You can just do all of these 4 bytes, these 4 first bytes. Then you can go here. You can see it's 1CD06C8, and you can just do the following: 1CD06C8 equals 0xFF, and again you do the same. C9 0xFF, CA 0xFF, and finally CB 0xFF. So we know these are the flags. Also, to enable the flags, you need to set a syscontrol. So to do this, we're just going to open the kernel in IDA Pro. I'm going to open it, and we'll select the PS4 kernel by Socratic Bliss, and we press OK. So when we're going to do this, we need to find a string of bytes. The string of bytes is the following: rcmgr. So if we go here to an hexeditor and we write here rcmgr in small letters, we go here, we paste it here, we know it's this one, so we go to the IDA Pro. So it's doing its stuff. We can already search when it's doing the passing of the code sequence of bytes. It's already here, but you can just paste it again. Okay, and we search all occurrences and match case. So we search, we go to the first occurrence, and we wait a little bit. When we wait, it will just pass and make a couple of X references. This doesn't do the X references on kernels with symbols for some reason. I don't know why, but I'm still trying to understand why it doesn't work there. But it's essentially the same. You just search for this string, okay, and it will pass in a little bit and fulfill everything. It's not yet done because this is a new database. As you can see here, if you go to the X view, you can see the rcmgr tokens and flags. Okay, still is going to for the last pass. Still going. So it should be able to fulfill the rest when it reaches this part. You can see the arrow moving, and it's slowly fulfilling the bar. When you have a full blue bar, you have all the functions labeled, and you should have a full gray bar here in the right side until this position, more or less. So it's still going. It's almost reaching the spot. Should be around here. Okay, already passed. As you can see, it already created some X references. Okay, you can see the gray bar being filled slowly. It's filled. Okay, so you can see the X reference here. You go to the first one for the internal development flag. You click here in the data X reference, and you start going down. So this is the first one, which is called int dev. So we click on the letter N, and we name it int dev. Okay, it's named. Then we go below a bit, and we see here that's psm int dev. So we click on N, psm int dev. We go below a bit, see here SL debugger. So this one is SL debugger. We go a little bit down, debug menu. This is for the debug menu that you usually see on the consoles. Debug menu. And we go a little bit down, debug menu mini. This is for the mini debug menu. Okay, going a little bit down. This is for the flagged updater, and I just type flagged updater. Okay. It's always the middle one. You see the offset, you see the function, and you see an I. So this force update, special I, then again fake finalize, then PSN access trace log, and we go down, bat update test, and we put bat update test, and we go down. This is to enable all the KF flags above, so you can put here any KF flag. This will enable all of them if you have everything set as FF. This is for the uToken flags. So uToken store mode, uToken.execution. This is for uToken weaken port restriction, uToken weaken port restriction. Flag updater, utoken flag updater. Utoken NP environment switching. Utoken save data repair. Utoken fake share factory. Utoken use soft Wagner, and I believe this is the last one. Use soft Wagner. So this is the 5.05 kernel, so flags may change across the firmware, so you need to do this thinking the best way to do this. Okay, so at the bottom you should see the not before, but this is an LU, it's not an I. If you go to the top, you can see this is an I and the other is an LU. So this is to say the LU is not to touch. You just need to touch the I's. So you go here to the functions window, you press U, and you see here all the utoken functions, and then we start with the int dev 1. So we go here to int dev, we press F5. Okay, I think I did the wrong one. Let's see, F5. We need to patch this condition. This one needs to be patched. So how do we patch this? First we put this on text view, then we see here a JZ, see another JZ. When we have two JZs, it's always the second one, and this always ends on 6. So, well, you go here, we go here to the X view, you can see that it says 74 1F. So first we need to rebase. We go here to the functions, edit, segments, rebase program, and we rebase the program to 0. Okay. To give a warning, but it doesn't matter. Okay, it's already rebased. Now we click here on the int dev if it lets me. Let me see if I can still. Okay, so I need to press utoken again. Okay. Okay, so if you go here to the second JZ, we see it ends in 6 to 8F226. So we note this down. So we go here to our Notepad and we put 28F226 will be equal to 0x1990. So we keep going to the bottom one, go to PSM int dev, we check the value, so we see it as a JNZ here. So if you have a JNZ here, it's always the second JZ. So first JZ, second JZ, and always ends on a 9. So we go here, we copy this, and you can see to 8F to E9. and always 0x1990. If you have any questions about which one is it, which one isn't, you can always press F5 and you can see it's the correct one. So we go down again to SL debugger. First JZ is here, second JZ ends on a 6. We go here, again same stuff, and we paste here. This one equals 0x1990. Same stuff. So we do this for all of these values until the soft Wagner 1. So if you go here, this is JZ and this is JZ, so a 6. And I'll just put here the 3 dots, so you know you have to do this for all of them. And you put equals 0x1990. Okay, so the flags are all set. There's also another way that you can set the flags. I already told in the other chat, in the other video, how to do this, which is to follow the template by my friend FlatZ and see how they are enabled. For example, the store mode is equal to the uToken flags 0 and 1. So instead of doing 1C D0 6C8 equals F0xF, you just do or equals and then 0x01. So this is for the start mode. You can do this way, you can do this way, you can just put all FFs before the magic and all FFs after, 16 FFs. So either way is possible to do, but I prefer this way. This way also works. It doesn't matter really. So after you do all these flags, you close the kernel dump. Yes, first I have to tell you how this works more or less. So let's see if I can teach you a little bit. So this function is I will just label this as permissions of root. It's not this the correct name of it, but it's more or less to tell you that the value at the process has to be of max permissions, more or less. So this condition is another condition that I don't know what it does, and since nobody has any idea of what this does, they just patch it out. And this function is memory compare, memcomp, and this function is syscontrol handle int. So they just handle the integers of these conditions. So if v6 equals 1, they just set it to 1 when you're doing the syscontrol. They do a memory comparison of the flags, and if the if the value and 4 is different than 0. So to do this, the flag must be set as 4. Then v6 is equal to 1. So this is one of the examples for int def. The key flags on the position 0 and 4 has to be different than 0, and then it will work for the sys control. So after you do all this, you need to do a couple of things in the code. Let me show you. You go here to the all flags. I'm going to share this on Twitter. If you go to the main.c source, you need a couple of things. You need the prison 0. You can find this, for example, on the Mira hen made by my friend the Kiwi Dog. Root vnode as well, and xfast syscall as well. This is for 5.05, so it was easy to find, for example, on xvortex hen. So you can see here the names and the description of the flags. And this is mostly what people use to get max permission. So first they start by just putting the ucred, the file description. They just increase the permissions. So first they get the kernel base, which is read MSR for this value, minus the xfast syscall, which is the very first function to appear on the kernel on 5.05. So 1c0, okay, as you can see here. Then the kernel pointer will be equal to the kernel base. The prison 0 will be equal to the kernel pointer of the prison 0, and the root vnode will be equal to the kernel pointer of the root vnode. So this is for max permissions. This is also for max permissions. This is also for max permissions. And as you can see here, the td ucred is going to be equal to the td plus 304. Okay, so this is everything for max permissions. Okay, so you need all this. Afterwards, these patches, as you can see here by the notes, 28F226, if you go here, 28F226, okay, 0x90, 227, 0x90. So as you can see here, 0x90, 0x90. If you go 28F to an E9, also here, 2EA, also here. 28F396, 0x90, 0x90, again. 28F396, 0x90, 397, 0x90, and so on, and so on, and so on. If we count these ones, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we see 20 flags that we must enable. One of them enables all, so it's not necessary, but we can just set it if we want. Then we have here all the settings of the flags. So if we go here, 1CD 06A8 or equals 0x1 is for the flag updater. And so on and so on. You can see here all those. Okay. After they are everything is patched, you can just call the syscall to the enable of the flags, and then you call the syscontrol by name. You resolve it for the libkernel, and you call anything that you want to call, which is usually machine dependency dot rc manager int dev or rc manager psm int dev, according to the name that you have figured out by the kernel. So all this. That is all for today's tutorial. I hope you guys enjoyed it, and I'll see you on the next time.